Okay guys, so in this video I'm going to walk you through subscription detection. And why would I want to do this? Well, because I wanted to show you what a real-world algorithm looks like basically. And this is just a subset of the real algorithm that I work on, but it's going to be enough to demo how a real world money making algorithm actually works out in the world. So let's get into it. The first thing we want to define is a few of the domain objects. So we have an interval, a payment, and a subscription, and then we have some tests for those subscriptions. So let's start with the basics first. What is a payment? The payment is what we're going to get from the bank in order to detect if somebody has a recurring payment plan for some type of service. So let's just walk through that. First and foremost, we put an ID on the payment, we have a recipient, and we have some type of cost, and then we have a created at date, in other words, when the payment actually happened. And we have a basic constructor that just instantiates everything and does some error checking to make sure that we're getting what we're looking for. Then finally, down here we have an equality check so that we can actually check if two payments are equal, so that we can filter and we can compare and basically do some basic testing on the payment. Now you may ask, okay, so you're using an ID here to compare these two. Why are you doing that instead of just comparing like the cost and the date and the recipient? Well, it's actually simple, because if you have two payments, you can, in theory, like the banks could send us information such as, all right, like where the data is actually the same, that a person can actually have made two payments basically at the same time to the same recipient on the same day. That's why it's very important that each payment has a unique ID of some sort. And then we have a comparison so that we can sort these payments, and basically we just look at the creation date and sort accordingly, so that we will always sort so that the most recent payment is always in the start of the list and then it goes backwards basically. Right, let's look at the cost. That's a simple object as well. So a cost has a big decimal amount and a currency. And then basically what we do some validity checking here so that the amount is something and that the amount is greater than 0. We also have a convenience constructor here, which is because, you know, if we don't want to pass in the currency, it's going to default to Swedish crowns because, hey, we're in Sweden. Anywho, let's look at the add function. So you can add two costs together, and basically once again we make sure that the cost is not null, and then we make sure that the currency is the same, because we can't add two pieces, like two costs together, if the currency is different. And then finally we simply add these two amounts together and return a new cost object. Right, and then we have another equality check here basically, where we check if this amount is the same and if the currency is the same, and then we simply return that so that we can check if two costs are equal. Let's have a look at the currency. Currency is a simple enumeration where we have one type of currency right now because our system is, you know, we want to keep things simple for now. And that's basically what makes up a payment structure. Let's look at intervals. So let's look at the interval. An interval is just a set of payments, and it has a type, and it has a boolean that detects that we will set on it at a later date, when we have figured out if this interval is a subscription or not. So let's look at, we do some basic validation here, and then we instantiate our object, and then we have a getter and a setter for the mutatable values. As you can see, I really like putting things that are not supposed to change in the future as final. That's just my personal preference. Let's look at the interval type. And here we can see that we have different types of intervals. We have weekly, bi-weekly, monthly, yada yada yada, and yearly, and so forth. And this is just so that we can identify what type of interval we are dealing with. Now, let's look at the interval matcher interface. Actually, this is a fairly important piece of information, or rather an important interface, because as you can imagine, you saw that we have different types of intervals, and because we have different types of intervals, we don't really want to have like this super algorithm that tries to figure out everything, because that function is going to be massive. I mean, let's say that we get even more interval types. We could have all like hundreds of different types of intervals. So in order for us to kind of get away from having this massive superclass that handles detection of all types of intervals, because that's going to get really messy really quickly, what we want to do is that we want to create an interface that we call interval matcher, so that we can actually create different classes or implementations for different types of intervals. So in our easy little case here, we only have one type of interval matcher that is called the monthly interval matcher. Let's walk through this. So what it has is two functions. It has this overridden function that we saw earlier on the interface, which is called getInterval. And internally, all it does is it does a call to a static function that is going to be this function here. Now you might ask, why are you making this a static function? And I actually say that I'm really making it a static function only because I don't actually require any type of field variables or anything like that. I just really want a pure function that does the computation for me. I will change this in the future if I would need like instantiated field variables or something like that. But let's walk through it. So first and foremost, we make sure that we have more than, or that we have at least two payments, because if we don't have two payments, then there's no way for us to to check if the dates are 1 month apart. So that's an important thing. We make sure of that. Then we create a result list and a sorted list, because as you may know that sorting a set is not all that easy. So we create an array list so that we can actually make sure that the payments that we are receiving are in a sorted order. And then we have the sublists index, which is going to make sense in just a moment. So we increment that by 1. And now as we iterate through the sorted list of payments, we grab the first payment, and then we check if this payment is part of an existing interval, because if when we go through this loop, we're going to start creating these intervals, and it's very easy just to check if something's part of this if this payment is part of any of our existing intervals. We have another for loop here, which goes through our results, grabs each interval, and just does a intervals.getPayment.contains on that payment. And if it found the payment, we simply tell the function here that we already have that payment. And if we already have added this payment into some interval, we simply continue, because in theory we can't have a one payment can't be matched against multiple intervals. That wouldn't make much sense now, would it? Right, then we have our sublist, because we don't want to iterate over things that we already, we want to exhaustively empty our list. So we create sublists. For each element we go through, we just create a smaller and smaller list until we have traversed the whole array. And then we have this magic function that is called find matching payments. We will look at that in just a moment. And finally, we check if there are any matching payments. Then we create an interval with this build interval function, and it's a silly little function that it takes the payment that we currently are checking against and all the matching payments to that payment, and we create our interval. And then we finally add that interval, and then we keep on going through the loop until there are no more things in our list. Basically, that's what's happening. So let's look at find matching payment. So we're taking the payment we want to check against and the sublist of payments that are coming after this payment, right? And first and foremost, we create our result array, and then we have we create a month difference initiator. So basically what we want to check is that, okay, we have our payment, go back 1 month into the past and check if you find a payment that matches that date. So we go through all of our payments, we grab the next payment basically, and we check the recipient and the other payment's recipient and basically what we do is we check if these two are equal, if they are the same recipient, and then finally after that we check if they are 1 month apart. As you can see here, payment minus month difference, that's going to be 1 at first, and then we check if the other payment is going to match against that date. So finally we then check if we have the same recipient and if these two payments are 1 month apart. And then we simply add that payment to our result. And then we increment the month difference, because first we want to check if we can find something 1 month back in time. If we do find something like that, we go and check for 2 months and then 3 months and so forth and so forth. And that's basically how we create this interval. Now this is just for monthly intervals, but we will see that we will very quickly start adding more interval matchers into our code. So creating a factory is a very nice thing, I think, a lot of the time, where you can simply say that, hey, I have an interval type. Can you just give me a matcher that matches the type that I'm looking for? And if you can't find a matcher that matches something, just throw an illegal argument exception. So right now we only have the monthly matcher, but as we go through and we add more complexity, we will have the yearly, the weekly, the bi-monthly, so forth and so forth. Cool, so now we know how to create an interval. Let's take a look at our subscription. So let's look at the subscription. A subscription is a very simple object right now because we haven't added any more metadata to our system, but we want to keep it simple for now. So it's just a set of intervals, and you give it a set of payments, and it's going to check if the payments are null and throw an error if they are. Then it creates a linked a set of intervals basically that is going to be that's what we're going to instantiate. It gets a interval matcher of some sort, and right now we only have one matcher, which is going to be the monthly matcher. But as we add more matchers and more intervals to our system, we're going to see that there's going to be several matchers basically. And then we go and get the monthly interval, or the matcher is going to call a function called getInterval on the payments and get a set of intervals, and we simply add all the matched monthly intervals that we can find into our interval set, and that's all a subscription is right now. Now let's look at this thing here, subscription service. So a subscription service is what we're going to use in order to detect if an interval in fact is a subscription, because just having an interval doesn't, just because the sequence of payments are happening at certain time steps and to the same recipient and with the same amount of money, that doesn't make it a subscription. So we need a way to figure out if something is a subscription, and that's what this service is here for. And we have a single implementation here, which is very, very simple. All it does is that it takes in an interval, checks that it is not null, and then it has a subscription identifier factory that is going to get a matcher, and it's going to check for the type of interval we're trying to match against basically. So now we have a matcher, and it's going to call this simple function called isSubscription, which is just going to return a Boolean value if this interval in fact is a subscription. So let's look at that matcher thing, or rather the subscription identifier. The subscription identifier is a simple interface that has this simple function called isSubscription. All it does is it takes in an interval and checks, and it's going to figure out under the hood if this is a subscription, yes or no. Simple enough, right? And we want it to be an interface because, as we've seen before, we have multiple types of subscriptions, so we need different identifiers to figure out if something is a subscription or not, so we don't have these massive super objects that do everything, right? And our factory looks exactly the same as for the interval matcher. It's just that it does it it creates identifiers instead of matchers. So let's look at the identifier, monthly subscription identifier. So here we have our function, isSubscription. It checks, it does some validation checks, and it makes sure that we have at least 2 payments, because otherwise we can't compare and get the time step between the 2 payments. It gets an iterator and grabs the first payment basically, and then it starts to go. It does a while loop to check, like, as long as we have a next payment, we're going to go through this loop, right? So we grab the next payment, we check, do these 2 payments have the same cost, and do they have the same recipient? If they don't, if any of these are false, we're going to return false. It can't be a subscription if we have a bunch of stuff that, if it's not the same cost and it's not, the payment isn't going to the same person, then then we know that it's not a, it's not going to be a subscription, right? it's that's I hope that makes sense to you. All right, so now we know how all of this is working, like the bare bone basics of how we do these types of subscription identification. Let's walk through our tests. And if we run all our tests, we can see that, yeah, they're all green. So I've made these ahead of time, of course, and we'll just walk through the different examples. So here, for first and foremost, we want to check if that we throw an error, if, or rather, if we give it some basic validation checking just to make sure that our our subscription is actually throwing an error, so we can, if we are giving it something it doesn't expect, right? So we create a payments array, or a set of payments, and this is something that is fairly important. Whenever you're working with time, make sure that you don't instantiate the time objects inside of your objects, because it makes testing very, very tricky. A good rule of thumb is to always instantiate time objects and then pass them into whoever is going to use them. So you can see here that my payment objects takes in a recipient of foo, a new cost, and a created at date, which will make testing much, much easier. But as we can see here, we expect this to throw an error, because now we try to create a subscription with just one payment, and we know we can't do that. So we just make sure that that's throwing an error. Let's move on. And here we have now 2 payments. As we expect, we instantiate the subscription, and we expect the subscription to be equal, get the interval size to be 0 basically. And why do we do that? Well, that's very easy. We see that our test is named test return empty if 2 payments are not the same recipient. You can see that recipient foo and recipient bar are different, and therefore this cannot be an interval, because we're not paying to the same, we're not making these payments to the same recipient. All right, so those are the basic tests. So let's take a look at a 2-month matching. So here we have a test that basically checks, we do the same thing here, and this time the recipients is the same, the cost is the same, and the creation date is the same. And here we see that, all right, we go 2 months back into into the past, which is not going to be a monthly subscription. It could be a bi-monthly thing, but because we only have, like, our test is intended to just test if this is a monthly subscription, this is going to fail, or rather the interval that's going to be, the intervals are going to be 0, because we can't create an interval basically. Let's move on. And finally we have a test that is going to check a similar thing, but this time we actually have a monthly subscription. We have 2 payments with 1 month apart. We add both payments, and then basically just make sure that we get a single interval, and then we check that that interval is of the type month or monthly, and then we check the payments and make sure that the expected amount of payments that we get in this interval is the same as the payments that we put in, and then we just check that both these payments are actually found in the expected payments. So we make, so that we are sure that everything is as we expect it to. I hope this is making sense to you. Alright, let's have a look at 12 monthly payments. Now this is the exact same test as we saw earlier. It's just with a lot more data, just because that's a good rule of thumb to have with you. You test for a simple case, and then you test for a large case, or like a larger case, just to make a sanity check. And you should always test for failures as well. You always make sure that you're checking both the happy case and the unhappy case. Now let's throw some stuff into the mix here. Let's try to make a interval with payments that are not as clean. Here we see that we have one payment for to one recipient, and then we have another payment to some other recipient, and then we have a payment to the same recipient. But we see here that the time step is larger than 1 month. It's 5 months, so this shouldn't be matched either. This cannot be a monthly. This payment cannot be part of a monthly subscription, because the time step is too large. And then finally we have a payment to the same recipient with 1 month, where the time step is correct. We add all of this in, and we assert that, we have one interval. We assert that it's going to be a monthly interval, and we make sure that the amount of payments are expected payments are 2, and that payment 1 and 4, which are these two here, are part of that interval because they make up a interval for us, or rather in our current implementation for the monthly subscription detection or monthly interval detection, this is going to be an interval. All right. And then finally we will check what happens if we have two intervals, because remember that it's in theory it's possible for a user to have more than one subscription. So here we have a payment that's going out to recipient foo and one to bar, and then with 1 month step distance between the two, it has another payment to foo and one to bar, and we add all of this into our list. And then finally we check that the interval size is 2, because these are twos, because we are paying to two different recipients and both of them can be matched and create an interval. We expect there to be 2 intervals. We check that they both are monthly, and then we simply assert that the amount of payments in interval 1 is 2, and that payment 1 and 3, as we could see earlier, are in that interval, and then the same thing for interval 2. Easy peasy. So these are the basic tests, and now I wanted to touch on something that is going to hopefully illustrate why this algorithm that I'm showing you now, it's a fairly straightforward algorithm so far, but it's a very limited and very basic one. I'll show you why. So we instantiate our subscription service because now we want to check if our subscription service can detect if an interval or a subscription an interval is a subscription. So we create a set of payments, we instantiate a creation date, we create 2 payments, add them to our payments, we create a new subscription, and we get the intervals, and we assert that these intervals are in fact 1, because we should only have 1 interval. We get that interval, and then we give that interval to our subscription service, and it's going to return true because, as we've seen earlier, this perfectly matches an interval, and we have seen earlier that the way that we detect if something is a subscription is if it's to the same recipient and it has the same cost. Basically, that's how we know it's an interval, or rather, that's how we know that's how we decide that something is a subscription, right? And then we have one failure case here, where we do the same setup. And the difference here is that we have 2 payments to the same recipient, and the time step is correct, but we see that the cost is different. And that's the key thing here. So now we assert that this subscription this is in fact not a subscription because the cost is different. And hopefully this has all made sense to you. Now I wanted to walk you through just some thoughts around all of this. Let's start by looking at how we detect if something actually is a subscription. What happens if the payment is the same on each month, but it is not a subscription? Perhaps a user is simply buying something for the same price at the same time. This is a problem because a subscription can, in theory, or rather, a user can actually go, and this happens especially when it happens to us all the time, when a user goes and has a very regular habit of paying for something at a store or something like that, that's going to, as we saw earlier, our interval detection is going to pick that up because the payments are the same amount and they are going to be with one week in between or 1 month in between, depending on how many intervals we have. So we have to start thinking about how do we deal with that case. What happens if the payment is 1 day earlier or 1 day late? Really big companies like Spotify, for example, they are really good at this. They always have the exact same amount that they draw from your account, and they always do it they're very punctual. But this is far from reality. A lot of companies will differ on 1 day here and there when they're actually getting your subscription fee. And this is about now we realize that, hey, our interval matcher isn't all that good, because our interval matcher is just assuming that a payment is always going to be exactly 1 month apart. But that's not true. Sometimes it's 1 month and 1 day, or like 1 month minus 1 day or 2 days, or like it could vary a slight amount in time. And so we need to start thinking about, maybe we need to rewrite that logic and figure out how we can deal with that. We also realize that we don't have enough information, because as we saw here in earlier, I was saying that, how do we know that something is a subscription and not just some random person buying something in a store? Well, it's very difficult for us to figure that out. In order for us to really know that, we might have to figure out what type of payment method they use. If they use if they use a credit card or something like that, then maybe we could be sure that that's not a subscription. Or there's all kinds of things that start creating problems for us. And finally, this thing that we are dismissing something as not being a subscription just because the price changed. Let's examine that for a moment. What happens if the payment amount is different? Should it be a subscription? What if the subscription provider is offering our user a special deal for 1 month? Like gym memberships, they do this all the time. You pay a little less for a little while every month, and then after a certain time period, the price goes up. What if the user changes the subscription plan? All these questions, and as you can imagine, this gets really complicated really quickly, and this is why this algorithm that I'm showing you right now, this is actually just the base algorithm that I build, I'm working on at my company, because it's just catering to a perfect scenario. This is a perfect world where everything is working perfectly and everything is super consistent. But as you can see here in my comments, code is easy when the problem is easy, but in the real world, problems are very hard, and there are tons of exceptions to our beautiful code. That is why I want you to focus on getting good at writing maintainable code that can change easily. That's why you saw all these factories and interfaces earlier, because that is something that will scale over time, because we have to accept that this is a very big, complicated problem that changes over time, and the implementation will change a lot, trust me. Complicated algorithms like this need a lot of tests, and the code will change over and over. So please remember this lesson. Real algorithms are difficult and take a lot of tries to get right, so always account for that when you work. Remember, when you deal with a really complicated large problem like this, you will not get it right on the first try. So think about that. Always account for that something that is this complicated will take a lot of tries to get right, so that when you create an architecture for your solution, you remember that your solution will change over time. And here are my 2 golden rules for writing software just in general. Code always changes, always, especially something as complicated as this. It always changes. And problems are rarely as easy as they first seem, because trust me, when I first started this little video of mine, I'm pretty sure that when I first started my job, thought subscription detection, well, that can't be all that tricky, can it? Hopefully you enjoyed this video and have a great day.